Okay, let's get going. So, my name is Ryan Thornley. I'm from a company called Deep3. I've been working quite a lot with serverless recently. I wanted to talk about some of our experiences. I wanted to be very open and honest, so there's some things that worked for us, some things that didn't, and kind of how we see serverless progressing, and certainly in the work that we're doing. So, these are some of the companies that we work with. We work in quite a varied amount of areas, so some of the places we can't use cloud at all, but where we can, we like to use AWS as much as possible. I'm certainly a big fan of Amazon Web Services, like whole platform. It does mean that we've got a big focus on security though, so we have to kind of really make sure that the things that we're producing are very secure. I mean, just generally is good practice, but also because of some of the customers that we're dealing with. So why we use serverless? So I'm seeing quite a lot of these kind of bids coming out where government, they ask for certain things, and one of the words is kind of low maintenance. I'm kind of taking this as we want something, but we've not really got anyone to look after it or manage it or just kind of make sure it's working. And I think serverless fits that bill really well because you can deploy something, and if you configured it correctly, it only really needs kind of a little bit of monitoring and kind of software updates and things like that to keep it secure. Certainly like long ongoing maintenance is quite minimal. You pay for value, so obviously one of the big benefits is you only pay for it when you're using it. Now quite a lot of the applications that we put together have kind of been ones that we want a huge amount of scalability, but it's quite feasible for days on end that no one will be using them. And in that situation, again, having a server stood up, someone monitoring it, someone looking after it wouldn't really work too well. So, that's a big deal for us that, a well-engineered application, if sat there, can cost you nothing. It can be scalable, so, the burst loads are great. You can have 1,000 Lambda functions all in flight at once, and that can give you some really great scalability, and it is kind of built into the platform. It is sometimes easy to cause problems with that, which I'll get into shortly, but that's certainly one of the things that attracted us. Secure and reliable, that's a given. There's a lot of things that AWS have kind of done on your behalf. Obviously, you've still got that top layer that you need to do your own security on, but you can assume that Lambda functions are secure, you can assume that RDS is secure, and so on and so forth. And that leads me on to, there's lots of services to consume. So some of the serverless applications that we've put together, we've tried to make it 100% serverless, so there's nothing at all that is running 24/7. Certainly nothing that we've got to manage. So why not? I said I was going to be honest. I'm quite bored of serverless deploy again and again and again and again. It'd be nice if we could do everything locally, but especially with some of the things that we've been doing where we're interacting quite heavily with the AWS platform, you just have to redeploy either the Lambda function or the whole stack to see changes. It's strange because CloudFormation scripts are great if you're only running them every so often because they're just magical. You give them 5 minutes, they go away and deploy, but that round trip of 5 minutes can become quite tedious if you're trying to hone in on a very fine bug or something like that and just retesting things. The other thing as well, if you're trying to design an application like we are that's wholly serverless, there's quite a few services that you consume there, and if there's a key feature that's lacking in one of them, you can't just go away and fix that. It's part of the AWS platform. You have to re-architect. You have to find a way to work around the problem, and that can certainly mean that risks can be hidden a little bit. And one of the approaches that we take is to try and identify all those problems as early as possible when we're developing something, as to not get caught out. And finally, the other issue that we have really is kind of troubleshooting and monitoring. Obviously, you've kind of got CloudWatch where you can go and look at the Lambda logs, but if you're running 1,000 Lambdas concurrently, then that gets very messy very quick. The logs are grouped by the Lambda instance, which is not as useful if you're just trying to work out where the occasional error is coming from. And it's something that we'd like to see kind of, I guess, a more Splunk type console where we could search into things. Obviously, we could implement that in our application and just not use CloudWatches heavily, but we're trying to keep as many AWS services in the loop here as possible and not have our own reliance on kind of third-party services that we have to manage and keep a server running for. So here's an example of one of the things that we put together. This was done in a hackathon, so it was just a bit of fun for a couple of days, as part of a company exercise. We'd seen that you've got Amazon Transcribe and Amazon Comprehend, so we wanted to see could we take a user's YouTube URL, scrape all of their videos, and then transcribe them to MP3, send that over to Amazon Transcribe to get the text, and then finally send it over to the NLP analysis, so comprehend, or if you wanted to use your own, you could use OpenNLP, and put that into Elasticsearch. So what this application actually did, on the way in, it took a YouTube username. It then went and downloaded all the videos, got all the audio, then got all the text, then got all the sentiment of those and the places that they'd mentioned and the locations and things like that. So it was quite an interesting way of getting a summary of a person. So, they might not put the location on a profile, but, if they mention enough surrounding areas around Manchester, could you then infer they're in Manchester? And Elasticsearch, obviously, you can use that within AWS as a service. You've got Kibana on the front of that. You can do some nice dashboards and things like that. So it was just an experiment. We just wanted to try out some of the AWS services, and it did work quite nicely. And obviously, you've kind of got that event-driven where you drop files into an S3 bucket. That launches the Lambda function and does the processing on your behalf. So there is some problems with that architecture, which I'll get into shortly. So this is something we've been working on more recently. It was a customer request, so I can't go into the exact capability of what it does, but this is kind of the top level of it, really. They wanted to scrape their own website, so they wanted to recursively go through and look at every single page, perform a small process on it, and then report back effectively. So that was something that, it fits this kind of application model of it's not going to be used that often, but when it does, we want it to run really fast, scraping thousands of web pages. And when it's done, shut down again, don't cost anything. So yes, that's what it's doing. It's taking a screenshot, it's going to export all the HTML, the DOM, and it has this admin UI, which in an ideal world, no one will really be looking at. It's more around just checking the status, and if there is errors that are flagged up on it, someone can go and have a place to look at it. So we're going to use Lambda Functions, obviously. That's a key part of the serverless architecture. Amazon themselves say, don't interfere with the underlying context and the Lambda function itself too much, but you can do it. So one of the things that we did is we brought Chrome, so we compile Chrome in a normal EC2 instance using Amazon Linux. That then makes it portable into a Lambda function, so we can upload that dependency as part of the package and then use Chrome within a Lambda function. So in this case, we're using Chrome because it's the best tool to take a screenshot of a website and also export all the DOM as well. Now, there's a couple of caveats. If you are going to start interacting with the underlying execution context of a Lambda function, it's easy to break things, and it's mostly around the kind of the reuse, because Lambda functions aren't brand new every time. They tend to live for about 4 hours, and if you're continually calling a Lambda function, stuff will land on that same instance over and over again until it kind of times out and gets replaced with a fresh one. So that means anything you leave on the disk will still be there. Any processes you leave running get freezed and thawed, so they will come back. And if you're not careful, those sort of things can catch you out. And the worst case scenario is you end up with kind of sporadic crashes as something reaches a threshold. It causes that Lambda to fall over, it stops processing, but new Lambdas come and replace it, so everything goes green again, and it can be potentially a tricky situation. So, how to break a Lambda function. So this is probably the easiest way to break a Lambda function. You've got a gig of space in temp, that's the only place you can write to. If you continually drop data in there, eventually your Lambda function will say no, and it'll go away and it'll crash. And that'll be kind of repeatedly crashing again and again and again until you get a new Lambda context that isn't full, and then it will start working again. So that's an easy one to mitigate. Obviously just clean up temp, or don't write files out unless you explicitly need to. In our case, if you're doing something with screenshots, you might need to utilize that temp folder to, let's say, resize it or something like that. There is other ways. So if you wanted to break an application itself, so I wouldn't recommend using Java and a Lambda function, but you can do it. So let's say you're using something like Spring Boot or Dependency Injection Framework. That jar file isn't kind of shut down and reloaded each time that Lambda function's reused. The jar will continue running. So if you've got things around dependency injection, objects floating around, they're going to continually exist between those executions. So our specific example was we'd spun up something that had the MySQL credentials in. That object was floating around. We made a call when the function first loaded to get those credentials. And if we changed the password then, the whole application would break because they were effectively cached within the application because that object was stale. So that was something that can cause you problems if you do end up using something that's stateful and you expect it to be clean every time. And how to break absolutely everything is to try and use Chrome and a Lambda function, as we found out quite quickly. So Chrome wasn't really designed for a Lambda function or to use headless, but it can be done. The issue that we had with that is that it really wanted to write to dev.shm, some shared memory, In a Lambda function, you can't write to that, which then caused Chrome to do something very peculiar internal. We think it crashed, but it left a zombie process. So we left that process running a Lambda function. Everything kind of looked like it was working okay because it did recover and made another Chrome executable that was sort of running. But when it goes round and round and round again, you ended up with more and more zombie processes until eventually the Lambda function crashed with some kind of vague error. We then had to then put debugging in, repeatedly deploy, try and work out what was happening with these zombie processes, trying to kill them. The fix in the end, if anyone's interested, is to recompile Chrome. You have to make some modifications to the source code so that it doesn't try to write that file out, and then it'll start to work. After that, it works great. But that was something that, it kind of, they do say not to do stuff like that. We did it anyway. We deserved it. But it did work quite nicely in the end. So now that we kind of solved those kind of core problems of, can we do this in a Lambda function, we set out to build the application itself. So we built an app around the scraping Lambda function. We set out to use as many of those AWS services as possible. Nice thing about Lambda functions, you can run 1,000 of them concurrently. If you're scraping a website, I found out there's not a fine line between looks like a denial of service and is a denial of service. It just is a denial of service. So we're obviously very concerned. We weren't going to run this against any kind of public websites without notifying them prior. We didn't run it against the customer website because we didn't have explicit permission off their web team yet. We did put it in S3 just to kind of give us a website to ping, and S3 obviously handled it brilliantly. My personal web server on a T2 medium did not. I have not seen Apache crash so fast before, but apparently if you run 1,000 Lambda functions against it, it does. So that was quite exciting, and obviously kind of brought about the urgent need for something to throttle back those Lambdas, which it does support, but that was also a bit of a problem when we got into it as well. So organizing the page scans. So the way that it actually works to scrape a whole website is we send in like the initial base URL, the kind of seed. A Lambda function will take that, it'll scrape the web page, it'll take that screenshot that we want, it'll take a snapshot of the DOM, but it'll also go through and look at any hyperlinks that are in that page. Any hyperlinks that are found, we actually want to re-queue, so that's the whole kind of recursive element that scrapes through a whole web page. Now, one of the ways you could do this is to use the asynchronous execution of Lambda functions. So you use the standard AWS SDK, you make the API call from your Lambda function to launch another Lambda function asynchronously. You do that over and over again to queue up all of these pages that you want scraped, and that's how you kind of complete the request. Now, we've got the throttling in there, so we're going to say now we're going to throttle Lambda functions to something sensible, let's say 30 concurrent Lambda functions. What happens is you can lose page scrapes. So there's not a proper queue here. There's no guarantees that when you go to a Lambda function or when you go to the API and say, I want you to run this Lambda function, if there's no capacity to run it, it'll have a good go, but if it fails, it'll just throw it in the bin. So this is a very easy way to kind of have a system that will work quite well up until a point, but once you kind of saturate it, it'll just start losing things, data will go missing, and you'll be wondering why this might be happening. So the example is that you can see that red circle there. You get 2 retries. So if you try and make a call to launch a Lambda function, all the Lambda functions in the 30 maximum we've got are busy. It'll give it 2 goes. After that, it will, if you've got it configured, throw it on a dead letter queue. If you've not, it'll just throw it away. There is no kind of automatic requeuing, so if it's on a dead letter queue, you've got to deal with it yourself. So that's SQS, simple queue service if you want to, or you can just send an email out, simple notification service or something like that. So it does work to an extent, but it's not the best way of doing it. The best way of doing it is to use a simple queue service. So a relatively new thing that they've launched, I think it was either late last year or early this year, is the ability to have Lambda functions as consumers for SQS. So it works like a normal queue. You can pass your data into that. It'll do all the nice queuing stuff. You get control over the amount of retries. You get lots of control over dead letters. It's a much better way of doing it. And the nice thing is that SQS handles the consumers for you. So it will try and create Lambda functions and execute them past those things. So you get in the event-drivenness of Lambda functions. If the queue's empty, there's no Lambda functions. If the queue's got stuff in it, it's starting Lambda functions. So we, on the surface, this looks great. We did have some problems with it though. So here's an example of kind of the scenario that we found. So you've got a simple queue service, you've got a queue, they're not ordered when it's working in this mode, so you can do first in, first out with SQS, but you can't when you've got Lambda consumers. You've got a series of documents that you want to process. So in this case, it's just the URLs that we want to scrape. There's kind of like a proxy consumer in place. So when something arrives on the queue, there's like this application that you don't really see, it's transparent, that will pick that up off the queue. It will then go and create a Lambda function and kind of pass that information to it. Once that's complete, the Lambda function will finish, return, everything will be happy, and then that proxy will go and delete it off the queue. So even though that message is within your Lambda function being processed, it's only kind of set to invisible on the queue. It's not removed until the Lambda function is happy and finishes and that proxy consumer sort of deletes it. If your Lambda function blows up, I thought it would be sensible if it just immediately went back on the queue, but it doesn't. It has to have this thing called a visibility timeout. So with the visibility timeout, after a set period of time, if it doesn't hear back from that Lambda to say I'm happy, it will then appear back on the queue. So you've got an additional delay there, and you can configure that as part of SQS. So there's that visibility timeout. So I've said here 20 minutes. So even though my Lambda function errored out seconds into its invocation, I'm still going to have to wait 20 minutes before that request there for page 1 shows back up on my queue and gets reprocessed again. So when I first found out about this, I was reading the documentation and I thought, okay, well my Lambda function's got a maximum duration of 5 minutes, so I'm going to set it to 5 minutes, 1 second, and that way things arrive back on the queue as soon as possible if there is an error. Don't do that, and I'll explain why. So the other thing that we've set, obviously, is the max concurrency. So in this example, I'm going to say I want a maximum of 2 Lambda functions running at any one time. So that's 2 possible consumers for this SQS queue. And in this situation, those kind of proxies they have taken 2 things off the queue, they've invoked the Lambda functions, there's now 2 of them running. Now, it would be nice if that was all that happened until one of those became free and then another message got consumed and it just kind of managed that fleet of 2 messages being processed at any one time. But it doesn't. Actually, what happens is that it picks up another one off the queue and it tries to find a home for it. So I guess internally what's happening is that it will try to create a Lambda function and hit the same concurrent execution limit that we would. So in this situation, it will hold on to that message for a period of time before giving up and putting it back on the queue. Now, if it gives up and put it back on the queue, that actually counts as an attempt. So in the same way, if your Lambda function had consumed it and thrown an error, it counts as an attempt. So does this process here, even though your code hasn't actually touched it. So we've got this situation where this message is trying to find a home, it's trying to find a Lambda function that it can be invoked on, but currently everything's busy. If it can't find one in that visibility timeout, it will put it back on the queue. So it will wait for 20 minutes in this situation. So the key takeaway here is that don't set your visibility timeout to be fractions of a second more than your Lambda maximum time. Set it to be a multiple of about 4 or 5 times. So if your Lambda function takes 5 minutes or a maximum of 5 minutes before you kind of got that hard limit, then set this value to be 20 minutes or 25 minutes, because that will give the system time to try and find a Lambda function to execute this on before it gives up. So the actual calculation it does is that it looks at the visibility timeout, it looks at the maximum time the Lambda function can take, and subtracts those. So if there isn't enough time to kind of, in the visibility time that's remaining, to do that execution, it'll just throw it back on the queue. So it's something that caught us out a little bit because we set the limit so close together. Once you set it appropriately, it does work quite nicely, but it's something that we didn't expect it to work like that. Okay, so you can set the reserved concurrency on the Lambda function itself. Obviously, you can do that either in the console, the web console, or you can do it as part of the CloudFormation script that you deploy. It's recommended best practice to set this on all of your Lambda functions, so even if you're not using it as part of your queue, just set a sensible limit on everything and it keeps things in check. There is a maximum of 1,000 concurrent executions that you can have, and those limits count towards that. So if you've got a system deployed that all of the Lambda functions within that system add up to 100 concurrent deployments, then consider them reserved. That means you've only got 900 left to use elsewhere, and it won't let you deploy in CloudFormation if you exceed that limit. So you should use it and manage it and keep on top of kind of where your executions could be. You can obviously leave it as just not set, and that, I mean, you can deploy as much as you want. but it does mean that you might one day have a lot of Lambda functions running unexpectedly, or denial of service in your website if you configured it in such a way. The max visibility timeout is another setting that you need to pay attention to, but that's on the queue itself. So again, it's the same thing. You can set that within the console, or you can set it in the CloudFormation. So we're doing all this via CloudFormation. It's all configured in the background automatically. And like I say, now that we've got it set with the values that work, it works really well. But when we got those wrong, it caused a lot of kind of weird, painful issues. And the final thing is the dead letter queue. So obviously, if something fails to be completed a number of times, so that could be that your system service is so busy that it just never gets lucky finding a Lambda that's not busy, or it could just be that there is a genuine fault, your Lambda's throwing errors all the time. A dead letter queue is obviously somewhere for those messages to go. Now you can put a Lambda on those dead letters, so it might be that you update your database to set things as failed, or you do some sort of process to highlight that these letters were a problem, so the messages couldn't be processed for whatever reason. And it's another kind of best practice things really. If you're using queues, you need to know where your data's going if you're dealing with thousands and thousands of messages. If you don't have a dead letter queue, then if there is an issue, how do you kind of narrow it down? How do you debug that? It's very, very difficult. So moving on from kind of that core scraping application, the data storage. There we go. So we wanted everything to be serverless. So I was quite excited when Aurora had the serverless option. So it's a nice one-click thing. You can turn it on and say, I want a serverless database. And the idea is that when you've made like a call to Aurora, it warms up, it'll be running nice. After a period of time, it'll shut down, and it'll cost you nothing until something else comes along and makes a request to that service to get some more data. It'd be really nice if it was faster. So the problem that we've got is its cold starts are really quite slow. So I think the documentation is quite vague on this, but it does say in various places it's up to 25 seconds. Now, API Gateway has a hard cutoff of 30 seconds. So what we found most of the time with this is that if you're using Aurora Serverless and you're using API Gateway and a Lambda function that's also probably cold, when you make a request to that API, the first one will time out, because it just doesn't have enough seconds in its lifetime to spin up the database and the Lambda function to do its thing, and that to start from cold and get back to API Gateway. So your first request always times out in the morning, which is quite annoying. It just needs kind of those 10 seconds shaving off it, and then it'd be a really nice way to work. But as it stands at the moment, we've all but turned off this option just because it just doesn't look great in the mornings when you go to your admin console and you try to load it, and it just appears to break in front of you till you hit refresh. So if anyone from AWS is listening, if you can make that quicker, that would be awesome. So in summary, this is the architecture that we've kind of got so far. So this is still a project that's ongoing. We've not delivered this yet, so we're still kind of fine-tuning it. But we're starting in the top right over there. So we've got that kind of SQS and that fleet of Lambda functions that will handle those page scrapers for us and do all the recursive goodness that extracts all the links and scans the other pages that it's discovered. As an output of that, we're using an S3 bucket, obviously, to store the screenshots. We put a nice life cycle on that, so those will expire automatically, and that'll kind of keep maintenance low. Like I said, there was an administration console for this, but we wanted people to kind of not have to use that unless necessary. So we used SNS to send alerts out, so you can link things up. We've got API Gateway in there. We authenticated that with Cognito, which is another great service for authentication. Aurora is the database. And then finally, to kind of put all this together in the kind of top-ish left over there, we had a Lambda function that was running as a cron schedule. So the idea is that we want to scrape the website once a day. That would start off that process by pushing the first seed URL onto the queue, and then it would all sort of kick off from there. One of the things we wanted obviously was a web UI. So the easiest way we found to do that is to kind of build something like an Angular app, or anything in TypeScript, whatever your framework of choice is. Deploy that into a S3 bucket. You can make that public, and that can kind of be then the link that people use to just look at the UI. So here's some of the things that we approach, developing things with serverless. So the least permissions possible. So we're using the serverless framework, and the way that we tend to work in development is when we wire a new service or wire up something new, we'll add in star.star. It's okay for development, you can do that, but we have a strict dev review process that unless you've got the IAM roles in place and they're sensible and secure, then we reject it like we would any other dev review. You need to go away and fix that. use key management or secrets. So secrets is great for kind of not having to pass things around security-wise. How are we doing for time, by the way? Overtime. A few more. I can skip through. Well, yeah. So encryption and also making sure you got your VPC set up correctly so you can use VPC endpoints so stuff doesn't go over public access. So I'll just go through this one. So we use secrets. The nice thing about secrets is you can create that in your CloudFormation script so that it will generate the password at kind of deployment time. So you don't have to store it, and then your application makes API calls to secrets to get in this case, the Aurora database credentials. So you're not having to pass that as environmental variables. It's not in your code. It's not in your CloudFormation script. It's all kind of secure and hidden away. Like I say, the Lambda functions make those calls, and you can restrict that via IAM. You can enable automatic rotation, which is an AWS provided thing. In summary, it doesn't work very well. So they provide a Lambda function, which is in Python. And the idea is it rotates your password. It might be related to that Aurora serverless, but what you'll find is kind of every third, fourth day, you won't be able to access your database because you won't know the password, nor will AWS. So that's something that we found as an interesting issue. We've not actually resolved yet, but yeah, I'd definitely try that one out because it is obviously rotating your passwords is a really excellent thing to do, but I just wish that worked a little bit better than it does currently. So I'll gloss over this because he's going through the steps of secrets, and then I'll skip through those. So that is the actual architecture we ended up with eventually. So we added in the secret rotation. If you turn off Aurora serverless, it should work okay. We also added in another Lambda function, which our deployment framework calls, which is serverless, to just run those migrations to stand up the database. And that's how we've ended up with something that doesn't have any sort of compute running all the time. You know, the migrations are done at that initial deployment, and it's sort of managed from there. And then we've definitely run over time. And then that's me. Thank you.
I wanted to make sure there was a little bit of time for questions.
Okay, go on.
Because we probably two. Right. First hand.
Hiya. Are you there? I enjoyed that. What software do you use to generate your architect diagrams? They're really nice.
So that's cloudcraft.io.
Thanks.
Okay, another question? That was a nice quick one. They're not interested, Ryan.
Okay, fair enough. I should clear off then.
Right. No, sure, I bet there is one more if we... No?
No, okay, we're done.
Right.
Cheers, guys.
So, yes.